All right, so we're first going to review fractions. Remember that fractions have a few parts. So we have the top number called the numerator. And the denominator is the bottom number. Now we have to ask ourselves, what does the numerator tell us? How does that help us when we see a fraction? The numerator is going to tell us how many we have shaded. And then the denominator is going to tell us how much we have in all. So how many parts in all. Now we also have a number like this, and that is called a mixed number. It's a combination of a whole number and then a fraction. And we can't forget a number like this. It's called an improper fraction. Remember that an improper fraction has a larger number in the numerator spot than it does in the denominator. Now the reason I'm going over these is because to add and subtract, sometimes we have to convert. We have to change the fraction. So we're going to quickly review how to change this mixed number to an improper fraction. So if you remember from class, we're going to multiply here, and then we're going to add here. 5 times 3 is 15, and then I'm going to add that to the 4, giving me 19. My denominator is going to stay the same. The denominator does not change. And so now my new improper fraction is 19/5. Now, if we take this improper fraction and turn it into a mixed number, I need to figure out how many wholes 9 has in 36. So I have to figure out how many 9s are in 36. Does 9 go into 36 equally? Think about it for a minute. It does. It goes in 4 times. So that's not a great example. There is no fraction on that one. It's just 4. But if we tried another one, say we did 38 over 9. I know that it goes into 38 4 times. 9 times 4 is 36. And then I'm trying to get to 38. So what plus 36 gives me 38? 2. So that becomes my numerator, and again, my denominator stays the same. So we need to review those in order to add and subtract fractions. Now, remember when we add fractions, whatever the denominator is, it stays. Okay, so when I'm adding fractions or subtracting fractions, that denominator is going to stay the same. I am not going to add those numbers together. The only numbers that I'm going to add together are these top 2 numbers. So this answer would be 4, 6. If I was subtracting, again, my 6 would stay the same. My denominator stays the same, and I subtract the numerators, and I am left with 2, 6. Pretty simple. Same when we're doing adding and subtracting fractions with mixed numbers. So if I have 3 1/4 plus 2 2/4, I'm going to add the wholes, I'm going to add the numerators, and that denominator stays. Let's try with subtraction one. Again, I'm going to subtract the wholes, I'm going to subtract the numerators, and my denominator stays the same. So all of this should be a review. The thing that a lot of you had trouble with, I'm going to flip it over, was the idea of what happens when I have an improper fraction at the end. When my sum, when I'm adding fractions, for adding mixed numbers in particularly, okay, let's try this one. 3 3/7 plus 2 5/7. My denominator stays the same, so I don't have to worry about that. I'm going to go ahead and add my wholes, and then I'm left with 3 plus 5 in the numerator. And my 7 stays. I can't leave my fraction like that. It is improper. Therefore, I need to keep my whole number. I'm going to put a plus sign here because I know that I'm going to turn this into a mixed number itself. Well, how many 7s are in 8? When I count by 7s, it goes in there one time. Notice this denominator stays. And 1 times 7 is 7. One more to get me to that 8. So 1 1/7 is equal to 8/7. So I have to add that new mixed number with my whole number that I already had. Okay, let's try one more. Let's get a little bit bigger here. So again, first step, add my wholes. Second step, add my numerators. Third step, keep my denominator. Now, I notice that that's an improper fraction. Therefore, I'm going to bring down my whole number, put a plus sign. I'm going to take this and turn it into its equaled mixed number. How many times does 9 go into 12? It goes in one time. 1 times 9 is 9, and there are 3 left over to get to 12. And then my 9 stays here. I'm going to add that new mixed number so that I get 10 3/9. Now let's talk about subtraction. When we borrow, that gets a little tricky sometimes. So I need you to pay close attention. So if I have 3 1/6, and I want to take away 1 4/6, I right away notice that my numerator is smaller than my other numerator over here, and that cannot be. I cannot subtract that way. I would get a negative number. Therefore, I need to borrow from the whole. I need to borrow from this 3 here. I'm taking 3 wholes away, or 1 whole away from the 3, so I'm left with 2. Now, because I took a whole away, I'm going to add that whole here. Okay, and my new numerator becomes 7. Now I can subtract. 2 wholes minus 1 whole is 1. 7 minus 4 is 3. And then my 6 stays the same. Okay, let's try another one. Okay, right away, I notice that my 3 numerator is smaller than my 5 numerator. So I need to take a whole away. When I take a whole away, it has 8 parts. So I'm going to add that whole over here. 3/8 plus 8/8 is 11/8. Now I can subtract. 3 minus 2 is 1. 11 minus 5 is 6, and the 8 stays the same. So that's the borrowing method. Some of you might feel more comfortable turning this into an improper fraction. I can multiply and add. just like I did on the other page. And now I can subtract pretty easily. 19 minus 10 is 9 6. However, I can't leave it that way, so I actually have an extra step. I have to turn that improper fraction into a mixed number. How many times does 6 go into 9? 1 with 3 6 left over. Okay, get the same answer, but I'm just turning this into an improper fraction. It cuts out the borrowing part.